Greetings, World Culture students. This is Mr. Schoaf.
Ms. Crouch.
And Mr. Jackson.
We are now going to take notes on map basics together using a flipped classroom lesson. You'll be completing your notes on a sheet that you should have in front of you. Watch and listen to the information on the slide, then fill in the missing information in your notes. You will be required to draw visuals and give examples, so pay close attention. Make sure to write down questions in the left column as you listen that we can discuss as a class. I will pause the video numerous times for you to take notes. After the video is over, ask clarifying questions if something is unclear.
All right, so the first thing we're going to talk about is what a globe is. And the definition of a globe is a spherical model of the Earth that is to scale. And what we mean when we say to scale is that it realistically represents the Earth's shape, distances from one place to another, and directions from one place to another. So it's basically the Earth shrunken down many times to a manageable size.
Hemispheres are used to divide the Earth into half spheres. We use the equator as the dividing line to divide the Earth between the northern and southern hemispheres. We use the prime meridian to divide the Earth east and west into the east and west hemispheres.
So that leads us to what is a map. A map is a usually flat representation of an area. Maps change a round sphere into a flat representation of a place. Is it possible to make a perfectly to scale, two-dimensional map of the three-dimensional Earth? Why or why not? We're going to pause it now so you can discuss. Okay, now what happens to the 3D globe when we try to flatten it into 2 dimensions? Your teachers are going to show you now.
So here are some good examples of how maps distort distance, shape, size, and direction. Look at the size of Greenland in the Mercator projection on the left and compare it to the size on the Robinson projection on the right. You can also do this with Antarctica. On the left, you can see Antarctica is enormous, and on the right, in the Robinson projection, it's much smaller. So we want you to think about what some of the advantages and disadvantages are of using maps versus globes.
Cartographers, or map makers, use different map projections to convert the round Earth into a flat map. These projections distort some aspects of the Earth in order to represent other aspects as accurately as possible. There's almost always some sort of trade-off. Showing more land more accurately distorts the oceans, for example, and so on. Please copy down the 3 projections, Mercator, Robinson, and Winkel-Triple, in the space provided. We will also pause now to take a look at an example of these projections.
We've told you about maps and globes, but we haven't really talked about why we use them. So maps organize our knowledge of the world and help us record where things are. People have been using maps for many thousands of years. As you can see in the bottom left, here's a map from ancient Rome. In the bottom right, here's a map from about 800 years ago. And on the top right, we have a Babylonian map, which is almost 2,500 years old.
So now we know why maps are made and how they're used. Let's talk about how to read a map. Most maps have these elements: a map key, which explains the lines, symbols, and colors used on a map. Examples that are commonly used on maps would be dots for cities. Sometimes the dots are bigger to show larger population. Lines are often used for roads or other transportation corridors. And green is often used for parks or forested areas. The compass rose, as you know from your world map, shows the directions and the orientation of a map. The cardinal directions include the main 4, north, south, east, and west. And the intermediate directions are between the cardinal directions: northeast, southeast, northwest, and southwest. Latitude and longitude is a grid system that helps locate places on maps or the Earth, which we're going to talk about in more detail now. Just kidding, we're going to talk about map scale first. So the scale of a map is the relationship between distances on a map and on Earth. So in the example below, the scale would be 1 to 100,000. The scale bar tells how a measured space on the map corresponds to the actual distance on the Earth. And that's often in kilometers or miles.
Here's an example of a historical map, which we'll get to more in a sec. This is a map of France in 1453. Look at the components that Ms. Crouch just talked about a second ago. You've got the compass rose, you've got your map key, and you have your scale and your scale bar.
General purpose maps are maps that show a wide range of information, both physical and human characteristics. The first type we'll talk about are political maps. They show the names and boundaries of countries, the locations of cities, and other human-created characteristics. Please take a moment to look at the map on the right and identify some of the political features of the map.
No, it wasn't.
Next, we have a physical map. The physical map shows landforms, water features, and other physical features that are not man-made. Please take a second and look over to the right and observe some of the physical features shown on this map of Brazil.
Another type of map is called a contour map, and contour maps show elevation from sea level, above or below. There's an example of a contour map of the northwest part of Mount Fuji in Japan, and there's also on the right a relief map that shows you the contour line map on the right, and then what that landform would actually look like if you were to see it on Earth.
Thematic maps are made to present specific kinds of information. Usually they show themes, patterns, or maybe a specific event. Please take a moment to write down examples of themes that could be showcased on a thematic map. You can come up with your own, please, or also here are some examples like climate, natural resources, vegetation, population density, and historical information.
So here's an example of a climate map of Africa showing the weather patterns over time.
Here's some more thematic maps. The one on the top left is population density map of Mexico, or how many people on average in 1 square mile. The theme here would be population. On the bottom right, you see a map of the Battle of Waterloo. It shows troop positions and ultimately one specific historical event.
Latitude and longitude. Lines of latitude and longitude form an imaginary grid that help us find absolute location on the surface of the Earth. We're going to pause now to take a look at Google Earth.
Latitude, also known as parallels, they are horizontal rings. You can think flatitude or latitude to help you remember. The starting point for measuring latitude is the equator, and that is 0 degrees, and it goes to 90 degrees both directions from the equator, and we'll explain this more when we start plotting latitude and longitude. You show the distance of north or south of the equator in degrees, and you can find your latitude on Earth actually by measuring the angle of the sun or stars in the sky. We're going to pause and talk about a specific example right now.
Longitude lines are also known as meridians. They're vertical half rings that start and end at the north and south pole. The starting point of longitude is the prime meridian line, and that's 0 degrees. And it goes 180 degrees both directions from the prime meridian around the globe. The distance is measured in east and west because it's east and west of the prime meridian. Longitude, unlike latitude, is not based on the sun's position on the Earth. We'll do an example of plotting longitude right now.